How's it going, everyone? Welcome. Euler Gonzalez here. And today let's go to now make a quick recap of the string behavior and then to explore about the number behaviors, which is one of the pillars of JavaScript. And because at the end of the day, I want to be able to describe is what is the pillar of JavaScript, not only for a professional aspect, but also if you want to explain now these complex topics to make it meaningful to others. This is the reality of senior developers or seniors in any field, right? So they learn and they understand how all of these complex topics relate each other's, and they now create examples that can be easily digested by others, right? Or as you can say, it's like numb down. This process of numbing down stuff is great if you want to explain now mechanical stuff, but when it comes to go beyond topics like explaining is about how you do the thing that you do and the art of what you do, this is not practical. This is not giving you the outcomes that you want. So, because right now we're doing is this just for explaining is the mechanical parts of JavaScript, which is made of these, the pillar of JavaScript as well as the asynchronicity. And because the pillar of JavaScript is the type system, the scope system, as well as the object system. So this is one of the pillar, and the other is the asynchronous nature of JavaScript, right? So here we have now to understand is concept like the the call stack, the web APIs, or the host environment, which is now JavaScript. The pillars are being executed whether it's on the browser or Node, all right, and as well as how actually JavaScript is an asynchronous language, which is at the end of the day is just relying is on the host directive or primitive that I provide by the language. So in other words, JavaScript is not a multi-threading language, all right, or doesn't know anything about that. It's just that the host environment provide now a way to handle with this asynchronicity, a specific input and output in the case of Node, and other asynchronicity methods. So for example, like the web API, such as the callbacks, all right? So the set timeout, this is a way of how you can create a synchronicity of that, or now delegate tasks to be completed at some point in the future. In other words, concurrency, the task that overlaps at a time, okay? And since here we look now at, again, this is go beyond the scope of this course, but it's important to at least understand that the main topics on the asynchronicity, right? Which is the callbacks, and then now the thunk, what this concept of thunks mean, and then the promise, and then how you can create is a way to mimic asynchronous behaviors to look like synchronous using now generators and the iterator patterns, and how you can use the promise encompassed with the iterator as a way to know how you can is create or recreate is, for example, the async and await behavior, right? In other words, if you're able to do that, you know what you are doing behind the scenes. This is also true for senior developers, and as well as how you can deal with series of eventual values, right? Using now observables and a particular library called RxJS. So we describe that because especially when you want to run your applications in JavaScript, because JavaScript now is a single thread. And you mean, what the F is a single thread? What the F is a thread? Here we need to know the difference between the process and the threads, where now a thread is a single unit of execution within a process, and a process is now a program that sits on disk, and the OS reserve spacing memory or allocate memory, so to load that instructions on memory, and then the processor can execute that. And all of this is known as the process. A common example of process are the program counter or the processor register, which now are physical part, our hardware in the CPU that is being used by the OS to reallocate some of the, you can think of this as some a closed space that the CPU can have access to when the OS put now data on it, right? A way to swap between data. So the processor register, we also have the program counter that indicate that at which point we are currently at in the code. The call stack or the stack register, which indicate is the function calls, as well as the memory page, is that how much space are this process taking. All right. One of the important features of the process is that it now has a special reserve space in memory. So when a misbehaved process, when a process misbehaves, it won't interrupt other processes. So this is something that Chrome actually use anytime that it create now a new tab, it create a new process behind the scenes, where this unit of execution known as threads, in the case of in the case of the browser, right? So the browser create is so the browser create now is the process. All right, well, or in other words, is the OS that is creating is a process, and inside of that you have now threads. So a thread, as I mentioned before, is a single unit of execution within a program, a process, and this usually at least you must have one thread. All processes have one thread. It is not unusual to a process to have multiple threads. Okay. And how now the OS determine when a process or a thread needs to be run. This is using a scheduler, and it's this scheduler that what it does is to manage is a process getting or sweeping, shifting between a process getting to the processor and a process get out, and it store now the state of this. And because storing this state is something that you need to keep track a lot of states, so not only is the program counter, the program counter, the stacks, as well as the memory page, but also you need to keep track is the OS, some complex data like the data, the kernel data structures, as well as how it's going to be assigned, how it's going to manage the virtual memory here, especially when you need to swap between different contexts or context switching, which is part of the thing that the schedule does. So why this is important? Because once you're able to understand that the scheduler or the OS is actually define the thread, which is the single unit of execution within a process, which is going to determine is what the process, what the CPU needs to process, what is the single small unit of the process needs to process, as well as when, and the CPU is gonna do that. Now, because context switching is something that is expensive, because now to keep track all of this state, as well as to manage is the virtual memory and how it's going to allocate that, all right? So this is not true for threads, since they now share the same memory, all right? But each one of those threads creates now is a particular process, like the process counter, the stack, and because of this nature, so we have now is in the server side, because if we now if we want to close this topic about the process and the threads and how now there are new ways to solve this context switching, which is using is the coroutines and fibers. Is now the application level, is the responsibility of the application levels to yield periodically tasks when needed, right? So again, I mentioned about these threads and the process because I want to make a quick intro about the node servers, and I know this is go beyond the scope of today's video. It's quite relevant due to the nature of JavaScript, but just to describe is the main three difference between is PHP, Java, and Java servlet, and Node as well as Go. So PHP, anytime that a server is created, is going to create a new thread, all right, or at least some older version. Traditionally, it creates now a new thread. It creates now a new process per incoming request. So as you can imagine, if your server is hammering with 10,000 requests per second, well, your CPU is gonna flame that. It's gonna get on fire. So again, this is one of the things that PHP older versions handle, right? So it creates now a new process per request, or traditionally. Whereas Java, at least Java servlet, it now has or create is threads per it creates threads per that JavaScript or that Java process. All right, it's gonna create now threads per incoming requests. But the problem is that this communication between threads is something that is going to be handled by the scheduler, which is, well, a lot of work for the scheduler, which is bad for the scheduler. Then we look now at Node, which Node, instead of actually unlike the PHP or Java say, hey, let me now write this code here to manage incoming requests, all right? Now it says, hey, let me write the code to start handling requests. This is the case of Node, and it's do that using a callback. So any input and output thing that needs to be done is gonna be used that, which is behind the scenes using the event loop, a library provided by this, which is libuv, that is going to handle this different phases of the input and output. All right, so first you have the timers, and then you have the pending callback for the previous phases. All right, each one of those phases I mentioned is a queue. And when that queue is empty, it's gonna go with the next one. So we have the callback queue. I mean the timers, the pending callbacks, the idle and prepare for the next phase, which is poll, where it asks two questions. How long do I need to block the input and output? How long do I need to block to poll the input and output, and then append all of that to the poll queue, right? So once all of that is done, then it moves to the next phase, which is the check. This actually verified in a specific callback, which is the set immediate, all right? And then it's gonna resolve is the close callback, all right? So for example, like socket.end, for example, like socket.end. So all of these phases is repeated every time that now an async operation is being handled, right? The problem is that once you get that data, especially for example, if you read a file synchronous or asynchronous, when you read that data and then you need to process that, the problem is that since JavaScript is a single thread language, it means that it's going to be used, it's going to block the CPU during that. This is a blocking operation, so it is not great for any CPU intense task. So what is the workaround is that only use JavaScript or Node for anything that is input and output heavy. If you need to handle is heavy lifting, or if you need to do CPU intense tasks, this is when now Go getting here. So Go behind the scenes now has a coroutine, which is an scheduler that allows you to say, all right, let me now is handle the input and output, as well as the let me handle any task here, and I'll be responsible for that. And when any input and output happen, I will block the main thread, or I will block the thread here. So because now Go actually is a multi-threading language, unlike JavaScript. All right. Let me do this. Where we are. You got it. So since Go is now a multi-language exactly, since Go now supports multi-threading through its concurrency model, is the model here that actually is something that we care about this. So in summary, while Go does not use traditional multi-threading in the same way as language like Java, it provides a powerful and efficient concurrency model through Go routines, which can be considered a form of multi-threading, right? So again, this is the reason why it's a much lighter than a thread, allowing thousands of even millions to run efficiently. Go routine. So this is the reason why, for example, you're going to see that a lot of, especially on the VC, San Francisco, that kind of stuff, a lot of these companies, startup companies, are looking out for someone who has Go experience, because this is something that can solve one of the issues with Node, right? And I think that's something that is worthwhile to consider it, especially if you want to now dealing with thousands of concurring incoming requests. All right, it also going to lower down the average cost. So yeah, that's something that is worthwhile to take a look. But With that, now finally we go to look at what we really care in today's video, which is the pillars of JavaScript. Now, the type system, we actually went through that to describe is first the primitive, and then the primitive and the objects, all right? The type of operator of that, to understand that this will give you now a strings of this, and therefore look at the kind of emptiness, the empty values, all right, and the values per se. Okay, so not only the kind of emptiness here, such as undefined, uninitialized, and undeclared, understand what is the difference between them. Some other operators, so for example, the null and undefined, they're called as nullish operators, all right, and the nullish coalition, which is something that we prefer to use. That you can use this as assigning a default value to a variable, right? And that's also great because you prevent these hosting things, something that we're gonna see that later. And the other is the nullish collision chaining. You have to be careful with this because what it is to say, hey, I'm going to check the property on the left. If it's not nullish, all right, good, now I can have access to it. If it's not, I'm gonna return now is undefined, all right? So it might not, the idea here is to improve the readability of the code, and despite that you might have some features, some of them are not good, they're not great to improve the readability of the code, because at the end of the day, somebody will gonna read that code, and you prefer to assume that when you write code and you deploy that to production, assume that somebody is going to, the next person that you're gonna see that it'll be a sociopath that is gonna pursue yourself if they see they cannot understand that. This is the thing that we have to elaborate, because we don't have any real impact on this kind of decision. And I think that unlike now a medical, namely a medical doctor or somebody that works in a nuclear factory, they of course has a lot of stake into that, and software developers have the luxury to not doing that. You know, it's like, what happened is gonna buy you in the long run. So the TLDR of this is that improve readability in your code. So we look at the primitive, also the objects, to understand now the values, such as the empty values, the type of emptiness, as well as the sum operators to handle these nullish coalitions values. Then the Boolean, which is something that is quite familiar, true or false, all right, and how you can flip one value using the negate. So string, which is a broad topic here, where now you can use a single or double quotes, and because the way this is represented is known as the JavaScript encoding characters, it's not only useful to know that UTF-8, UTF-16s, and if you think that, if you heard the terms and you know that you can see that, and you think that you know all, this is all of the thing that you need to know in the string, you're dead wrong. Why is that? Because the intrinsic nature of understanding this representation as well as its behavior. What do I mean by that? Well, that this representation, which is used now Unicode, which is the umbrella term to use a variety of character set, not only UTF-16 but also the USC or 2, as well as, but in our case, most of the time we use the UTF-16, which is this character encoding that represents all the universal character a computer can have in a number that go from 0 to 4 times f in hexadecimal, right? Or it go all the way up to 0 to 311. No, this one, how long is this? 3, okay, 3, 6, all right. Up to 1 followed by up to 1 followed by 6 digits, right? There is a particular range to that. I can describe that. But the thing here is that this is the range that this string can be represented. It use now 16 bits, all right? And this representation, all the numbers that can fit here, which is from 0 to 65, 353, okay, is known as the basic multilingual plan, right? So anything that go beyond that, right? For example, if you want to represent emojis and stuff like that, JavaScript use these 16 bits to represent as one character, but those symbols or graphemes that are beyond this this range, okay, now is known as the adjacent. Is known as the adjacent or the surrogate pair. But what it does is to take now this 16-bit, so add another 16-bit, all right, which is known as the surrogate pair, and this is now known for JavaScript as a length of 2, right? So now it detects this as a length of 2. So in other words, why do we even care about this? Well, because not only that, for example, simple emojis like the firework, all right? So not only that simple emojis like the firewall actually is now using this internal representation, all right? Oh, exactly. Its normalization should be is characters or FDD. Okay. So internally, all right, all of this, what mean is that this is the surrogate pairs, and when you use now surrogate pairs, any Unicode points that now are beyond this 535, it enter in their astral plane. And here we have, for example, this emojis, or now combinations of emoji, or in other words is clusters of graphemes, all right? So for example, if you are going to use now this constellations of graphene, and if you want to know the length of this, so what it's doing is saying, hey, now JavaScript is representing this as a combination of 2 surrogate pair, all right, where when you transform these surrogate pairs, okay, this composition, okay, when you convert this into surrogate pairs, now you have is this which represents one surrogate, and the other represent is another surrogate pair. Okay, so this surrogate pair individually, they don't mean anything. How do I know that? Well, we can is do something like this to actually know what is in there, right? And as you can see, this is what is represented here. It represents now this thumb down plus another emoji that is, this is the color scheme, but I don't know why it doesn't have that. It seems like this representation, so the current local doesn't have that representation, or doesn't know that representation, but internally it transformed that properly. So in other words, if you want to use now this, using escaping characters, as you can see, this doesn't convert to anything. The format that Unicode is used, it is through a U plus 4 or 6 digits or alphanumeric characters, right? So when you combine this, for example, like this, now actually the combination of those Unicode points, or this 16-bit representation, all right, when they merge that into a surrogate pair, this gives now a valid number representation of that string table that you have, right, of this Unicode table. So if you want to know what is the number of this, which is a good question, I must say, if you want to know what is the number of this, all right, you can map each one of those characters and say, give me now the character char Jesus give me the character char at the code point at that position, right? So give me the code point at that position. There are other methods here that we're going to explore, all right, when it comes to look at the behavior of JavaScript, especially with strings, all right. And as you can see, here is this decimal representations of that table, that if you want to try to get that, when you want to try to get that single unit, all right, you say from code point, okay, like this, is gonna give you the character that I represent. But let's say you want to say, okay, now I want to is the letter A, right? I want to know what the A means, or what is the Unicode of the letter A. You say, well, char code at is 97. So if you now look at the string from code point, I mean from code point, okay, 64, I don't get the A. So A is going to be the code point at that character is 97. So if you look now at this, is if you pass now the decimal value what it's gonna do internally, because JavaScript now has this table internally. It say, hey, this 97s in my table, in my hash, it represents now a, and it's gonna give you that. But the thing is that because of this numbers, that they don't represent anything, just this particular Unicode. When you combine this, so individually they don't mean anything, but when you combine this, all right, another way to combine it is doing this. So hey, I want to use this. So when you combine this when you combine this with this, so what you're saying is that, hey, I want to now get the value at your table, at your Unicode table, which is 55357. Well, it's gonna give you now this, and the same for 56398 is gonna give you this. And when now the JavaScript expression is evaluated, it say, hey, I have this Unicode point, and internally what it means to me is this icon here. So this is great to explain now, is this basic length, or the length of this, why this actually is now a length of 4, right? But when you want to now combine is more complex, it now give you is things like this. So it have now a length of 11, and you might wonder what in the F is doing this. So, well, you can quickly see here this per unit characters, all right? So it means that this icon here, this family icon, is made of this surrogate pair followed by white space, surrogate space followed by a white space, surrogate pair followed by a white space, and surrogate pair. So in other words, it's using now 3 surrogate pairs. That's right, plus 3 spaces, where each one of those surrogate pairs is made of the which each one of surrogate pairs is made of 2. All right, so you multiply 3 times 2, it gives you so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, right? That's what you have now, the length of 11 here. So these 2, each one of those surrogate pairs, which is 3, so you multiply that by 2. So 3 times 2 give you 6, and now is 6. So I will give you 6. I mean, it's 4. Sorry, 4. It's 4 surrogate pairs plus 3 white space. So if you want to look at what actually is this composition here of these surrogates, you can look at this and say split this into that, or you simply let now the JavaScript evaluate that. So here it represents by a female character and a female character and another male character and male character, right? So the point of this is, when you're dealing with characters and emojis, you have to be well aware of what you're doing, what is doing this comparison, because you might find out is unexpected behaviors here. And then we look now at the primitive, all right, especially the string. So what is a simple example of primitive string? That you can change the length of the string, and I think this is a very good interview question. All right. The other is how do you access to characters, similar like an array style. How do you iterate through characters? Currently, using is the for of, all right, which behind the scenes the string has now internally a private method, which is the iterator, uh, that now implements certain interface that any time that, for example, syntax that wants to iterate through some objects that follow that particular implementation, that pattern, now can have access and now retrieve those value as it is, right? So the idea here is that these hidden properties that you can have access known with the known symbols or well-known symbols to get that behavior, all right? And the point of this well-known symbols is to access to custom methods, the private custom methods for objects that has some hooks attached to. This is known as the metaprogramming, okay? So the metaprogramming here is to say, well, I'm going to is have access to these internal private methods that are defined, that are well defined, and symbols is one of the useful case of symbol is that it allows you to define some private method or access to those private methods. It doesn't return any value. It's just internally JavaScript create these unique labels. It now allows you to have access to these internal methods here. So if we look to the symbol or the well-known symbols in JavaScript, okay, especially here and the end, the well-known symbols, share symbol in global razor, now well-known symbols, okay. All static property of the symbol constructor are symbols themselves whose values are constants across realm. So they are known as well symbols, and their purpose is to serve as protocol for certain built-in JavaScript operations, allowing users to customize the language behavior. For example, if a constructor function has a method symbol has instant, and it is named as it is named, this method will encode its behavior with the instance of operator. So in other words, there are now specific return primitive value of type symbol. So these well-known symbols are a way of how you can have access to this. So in this symbol description, we will use language like symbol head instance is a method determined, but bear in mind that this is reference to the semantic of an object methods having this symbol as the method name, because well-known symbols act as a protocol, not describing the value of the symbol itself. So well-known symbol act as a protocol, okay, act as a way to have access to this. So symbol async iterator, a method that returns the default async iterator for an object. Symbol has instance, a method determining if a constructor object recognizes an object as an instance, use instance of. Is content spreadable, for example, so you can have access to collections here. A boolean value indicating if an object should be flattened into its array, used by prototype and concat. The similar for the iterator, a method returning the default iterator for an object. The similar for match, only for strings. As you can see, all of these well-known symbols to have access to. So. That's great. That's good to know. Then we look at the length computation, which is something that I briefly described. And when you are working with, because there's sometimes some particular characters are going to have they represent more length than visually it is. So one way to solve that is by normalizing. All right, so you normalize that, or okay, so when dealing with Unicode string, that will be compared. Exactly. So anytime that you need to compare, sort, or calculate the length of a character, it is very important to keep in mind the Unicode normalization. However, if you're going to compare now letters in a specific alphabet, we can use this now the internationalization for that, right? The internationalization, especially the locale compare, which is, hey, let me define now the specific alphabet here that I want to compare, and then actually it exposes a compare function for that. The new internationalization collateral here, similar to this. So that's good. That's great. This is for comparing now characters in the same alphabet. So you can, for example, sort things in a. So you can compare characters in their alphabetic order. All right, whether it is English or Spanish, French, or Pinyin or Chinese, or this romanization of the Chinese characters. All right. Here actually look at some couple demos to use that, and the other is that if for some reason you care about is to get the words in a particular string, we can use the segmenters to get the meaningful words out of that. Again, it doesn't include any emoji, all right, only words. If you want to use the emoji, well, you can specify that, all right, or create some sort of logic, or tell now ChatGPT or Claude to help you with that. I will encourage to do that. And the other is the string concatenation, something that I'm quite familiar. So anytime that the plus operator or the addition operator is being used, it's gonna prefer string concatenations, and then now the addition. How do I know that? Because you can take a look at the spec of how that is going to behave. All right. So on a string concatenation, let me actually quickly look at this, especially on the ECMA script here. There you got it. And here we have is the addition operator. The addition. The addition operator. You got it. All right. And well, it's the runtime semantic evaluation. You say, hey, return evaluate string or number binary expression, and here is going to tell you what it's going to do behind the scenes. The abstract operation evaluates strings or numeric binary expressions, takes argument left, and parse note the operators, a sequence of Unicode points. That's what is important to understand that. All right. And the right operand, a parse note, and return either a normal completion containing either a string, a big int, or a number, or a broad completion. It performs the following step. So if the left operand be an evaluation of the left, so call that the evaluation here. The syntax direct operations evaluation takes no arguments and return the completion record. And completion record is saying that, hey, I evaluate this expression. All right. I evaluate this expression. Be the operand. So in the else valve, be get the value of the left reference, and as well as this. So it's going to get the value of both. All right. And then it's going to now call the apply string or numeric binary operator. So if you take a look at this is actually where the algorithm in this numeric algorithm way is telling you what is going to do. If the operand is positive, I'm going to transform it into a primitive. If the primitive is a string, if the left and the right is a string, then exactly. If left or the right is a string, I'm going to convert is the other into string and return the string concatenation, right? And it's telling you the string concatenation. So again, you can take a look at that in your free time. Note at this point it must be a numeric operation, right? So otherwise you're gonna do now a numeric operation. If the number is a big int and then is this, so it's going to now calculate is based on this expression here, right? So for example, if we say according to this, hey, this is now a big int, or you can represent this like this, big int plus 2 big int, 4 big int, it actually compute that properly. If you pass now a multiplication, do that as well, it actually performs the negate or the subtract, all right? And here is telling you all of this. It also going to perform now is an OR, okay, bitwise or an AND, all right, bitwise AND or a shift or a shift left or shift right, okay. And that'll be the operand that is available for us, right? Even to power to that. Right, and so on and so forth. So here is when we look explicitly at that operator here, right? And what is this is actually doing here. So I think this kind of operations here are very important to at least understand, to read at the spec and to understand, to get now that ground, that solid ground that we need to know. We also look at the template string, which is the new way of how you can evaluate variables inside of a string. I think this is great. All right. And then some other, the common method here. String value method. So let's take a look now at the key. String value method. But I think I need to take a look at this. String value method. String value method. What the French services? No, get started. This is the type and grammar. String value method. Primitive behaviors, string comparison. You got it. Internationalization of that. Okay, string comparison. I don't mention too much about this because string comparison is something that we're gonna see and describe that later when we look at the abstract operation, which is part of the pillar of JavaScript. Okay, string concatenation. Then we look at the string comparison. All right. In other words, is the double equal, which is the abstract operation. Double equal and triple equal. Right? But what is useful here is through the double equal and how we can take a look at the algorithm here, which is known as the loosely equal. I mean, it's loose equality expression. Exactly, is loosely, okay, is loosely equal, which is here. All right, and here's where it is going to determine that. You can put it here, see, loosely equal is loosely equal, which is the double equal. Strict equality is strict. Is a strict equal. Right? Is a strict equal. Equal. All right, and the other is the object.is, which is, you can think of this object.is, which you can think of this as the quadruple equal, right? Object.is. So you can think of this as the quadruple equal, right? So once we evaluate, know what the algorithm is doing, all right, and some interesting cases, for example, like this. So what is the value when you return this kind of stuff? All right. So walk me through that. Okay. Which can be is now an interview question. There you got it. This is a view segmenter and collator. This is now an interview question, right? So yeah, we move on. All right. Okay. Some of these methods, we want us to dive deep into that, which is very valuable, right? So char add, exactly. Char add, where it gives you now is the position at that character. So it gives you the position of that character, right? So this is gonna give you is the position of that character. So for example, you say add. The great thing is that add use now negative to have access to. All right. So you go from backward to. So you can use now negative number here. All right. The other is the char code add and code point, right? The code units and return the whole code point starting at the specific index. If surrogate pair is found there, the whole character code point is returned. So char code and code point at this, right? So returns the numeric code unit of the character. So for example, if you say now, well, give me now the char code add, give me the numeric value of that character. All right. However, if you have now some surrogate pairs here, it's gonna give you now is the numeric code of each one of those characters. Remember that at the end of the day, this is length of 4. The length of this is 4 because now it's using two surrogate pairs. Or in other words, it's using now 4 16 bits to represent this plane, the astral plane. So what happened is that it's gonna give you is the code point at that position. All right. So you gotta be careful when you're dealing with this, because otherwise, well, you're gonna find out this. The other is a code char code add, and the other is a code point add. Allegedly, it is supposed to give you exactly. It's gonna give you now the surrogate pair. All right. It's gonna give you the surrogate pair. So for example, if we use not this, but we use now not a composition of surrogate, but we use now this, it's gonna give us is the surrogate pair of that, right? It's gonna give us is the surrogate pair of that. It's gonna give us is the surrogate pair of that. So in other words, this is now 2 as well. So if you want to know how this is being organized, is with this, right? It's gonna give you is the surrogate pair for that. So in other words, it's gonna give you is instead of the single 16 bits, it's gonna give you now the surrogate pair if it's found there. Okay. It's important at least to understand that. What is the value that you're getting from? All right, so far so good. The other is the substring and slice. Well, something that we are now quite familiar with. If you want to get some sort of string, say substring in any language, you say, hey, I want to start from in the index and then this one, I want to get from the index 1 and from that, okay. If you exceed the index, of course, it's gonna give you now is from that, right? So it's telling you it's like telling you this or this, all right, in this direction of how you're gonna get that substring. All right, it's more intuitive to say this, only that. So from this, I want you to get me this. It's similar to slice, right? It's no difference to that. These differ in how the range star and index are specified or determined. Then we have the two uppercase. Let me put it this. The other is the exactly substring. The other is the uppercase, something that I'm quite familiar with. So uppercase, lowercase, uppercase, lowercase, something that doesn't have any much more description. But to local uppercase and to local user case is now the local operations, or they use a local mapping. Use local mappings for user lower and lower operations. Okay, use local mapping for that. The other is the concat. You say, hey, I want to concat is this. All right, an empty string followed by a concat, and you can concat more of that, which is that's interesting. It add an additional space, exactly. You can concat and concat. You can chain these operations. All right, the concat produce a new string with the value that you pass here. All right, the concat. The other is the index of. So it's going to look at that position. So index of is going to look up at that position, and if that exists, it's going to give you now the value, right? Right, index of that. If that is found, okay, if the found, search string, say, hey, this one, no, you find it, okay, this is index of, but it's going to search through that string. Interesting. It's gonna search for that character here. It's like, give me the index of this. The other is the last index of, exactly, last index of, but now here, but from end to string. Exactly. So last index of, all right, it's gonna find from the last index if that string exists, all right, and tell you now the position of that or if you do this, for example, with this, it's gonna go with this as well. Why this is important with this last index of? Because the it's gonna be used is the LTR locales or ref or write TL locales. All right. So for example, is you're using now a language that starts from left to, so Jewish language is now go from left to right, similar for the Latin, but some Arabic language use now from right to left, and this is important to actually understand what is going on. The other is includes. All right, most of the time we use is the includes, which say, hey, yes, I find it, right? I could find that, like, or I could find this substring, you know. I think that's quite interesting, the include of. All right. The other is a search, but for a matching pattern, like search for matching patterns. Hey, is this pattern exists? All right. Similar to include, but instead of returning you the index, it's going to return you now is the specific regular expression. Hey, does it found? Yes or not? But again, it's gonna give you now is 0 or 1. Okay, so search give you 0 or 1, includes give you a Boolean values. All right, includes give you a Boolean values, a Boolean result. All right, search return you now. Search you now return regular expression matching and specify. It returns a number. Okay. It returns a number. The other is a trim, start, and end, which is great for actually removes trailing or leading or trailing white space. Repeat. All right, that's to me quite interesting. You can say, hey, repeat this text 3 times. All right. Repeat this 3 times. You also have now a split. All right. Produce an array string values and split as the specified string regulation, which is something that I'm quite familiar here. Say, hey, I want you to now split this given a specific regular expression. So split this for E, right? So anytime that you find that E, you're gonna split this. So if you find now an L, I want you to split that from that regular expression, okay? Or like this. All right, you will split. The other is adding padding, okay? When you want to add now padding, whether it's pad star or pad in, this is useful. For example, if you want to now create is strings. Let's say you say, hey, I want to create now a string of this max length 7, and fill that with zeros. You know, this is useful for generation of boundaries, or this, right? And then right below, yes, or this, all right? And then you can play with that. You can say is that, hey, replace, which is something that I don't see that, all right? Return a new string with a replacement of the original string, right? So padding, which is useful for that to create now for generation. For generation, with some particular pattern, right? The other is a start with, like this. The other is a match all. Yeah, start with is to find particular patterns. This is to check that. To say, hey, start with, let's say with this letter. If it is good, it is case sensitive. So that's what we need to say, hey, to lowercase. All right, and then I want you to now say this, right? Hey, this is you find that, or this, and so on and so forth. This is quite interesting that this says, oh, if you pass now an empty array, it becomes true. Holy fuck. Okay. But this is what you can do this. Start with, right? The other is a match. Return a new array for that. Hey, I want you to match if you find out you, alright? This is quite interesting, because now this will give you is regular expression and which groups it belongs to. This is more useful if you want to work with regular expression here. You want to do that, match is the way to do. All right. Interesting that it returned now these collections. Here. Hey, do you find it? Right? Do you find it? No. It returns you null. Okay, it returns you null. And you have to be careful with that null value. It returns you null. The other is replace. Alright. So you can say, hey, replace any value that you find, for example, all of the E with A, right? And then you got is this. So you're gonna do this linear search. That's quite interesting. The other is denormalize. Okay, for Unicode normalization. So for Unicode normalization, that's it. This is it. Normalize, and you can use a specific character for that. Local compare. This local compare is gonna compare the alphabet function and compare two string according to the current locale. Useful for sorting. Okay. Returns a negative number, usually -1, but no guarantee. So you say local compare, all right? If you say local compare of two string. Oh, but I don't think it's like local compare is not from here. So you must find this local. Interesting. Local compare. But I think this local compare method of two string. Okay. Okay, so for example, if you say so for example, if you do it here and then you say I want to now use a local compare, okay, where I want to compare this string and some of these options with the Spanish. In the Spanish, which is the collator, all right, with the range of this alphabet, that's quite interesting, followed by the sensitive base, followed by the sensitivity base, sensitivity base, like this. I prefer to use LED because I want to reassign those values. Local compare is not a function. Oh, it seems that Firefox doesn't have implemented that. Opera. Oh. They don't have access to it. Or locale. Ah, but there is a typo here. Okay. Locale compare makes sense. So they are the same. Exactly. Positive if the reference come after the compare string. Exactly. If the reference come after the compare string, it's positive. If the reference happens before the compare string, it's gonna return a negative number. Okay. There's another error here. It's locale here. It's locale comparison. Interesting. Locale comparison. So there is two errors here. So here, locale, and there was another typo there. Locale, and there was another typo here. Let's gonna move on. Exactly. Okay, we have here now typos, right? Typos. Locale compare. Locale compare. And the other is on the stream relationship, equality, that kind of stuff. Okay, good. So as we move on here, okay, with all of these methods, static string helpers. So the static string helpers, string concatenation, string comparison, Alright, string value methods. String static string helpers. Okay, like a string from car and from code point produce a string from one of the more arguments representing the code units from that to allows interpolation on a template, literal, but prevents character escape sequence from being parsed, so they remain in a raw individual input characters from the literal. Moreover, most values, especially primitives, can be implicit coerced to this string equivalent by passing them to the string functions, no new keyword. For example, here. Exactly. In later chapters. So yeah, this is the static helpers. All right, something that I am quite familiar with. All right, and then we jumped back to the string values. All right, such as the string values. Except with the string values such as escape characters, line continuation, multi-character escape, which is going back to the code here, line continuation, primitive values, string, strings like this. Character scope, escape character, escape sequence. Okay. Exactly, escape sequence. It's escape sequence. Escape sequence. Alright. Escape sequence, like new line, hexadecimals, Unicode. All right. Line continuation, if you want to do that. Multi-character escapes. Okay. Line continuation. Multi-character escape. Like this. This is what? Escape sequence. Okay, escape sequence. Multi-character escape. So for example, to represent is the ASCII, which is using 7 bits. Exactly. Our decimal values 169. Unicode in a string, which is escaping characters. Exactly. Multi-characters escapes, whether it is exactly multi-character escapes or escape sequence. No, it's this one. It's escape sequence, such as line continuation, multi-character escape, multi-character escape, ASCII, Unicode, right? So for example, like this. So Unicode escape sequence alone can encode any of the character from the Unicode BMP, okay? But it can encode this basic multilingual plan. They look like you followed by exactly 4 hexadecimal characters. For example, the escape sequence is this, exactly, corresponds to the same symbol, while U corresponds to the Unicode character with code point this smile face symbol. Okay, so this is the copyright character. All right, but Unicode escape sequence alone can encode any characters. Exactly. ASCII, for example, like this. Unicode in string. Unicode sequence. Unicode sequence can encode any character here. Can encode any character from the BMP. Can encode, exactly. Encode, or in this case will be the code, by the way. Any character sequence alone can encode any of the character from the Unicode MVP. Okay, exactly. They look like following exactly 4 hexadecimal characters. Exactly. They encode any character from the Unicode BMP. Unicode Seeker can encode characters from the Unicode. From the Unicode BMP. Okay. So, like this. Okay. Which is this one. So when JavaScript evaluate this, all right, you say, hey, yes, this is it. So copyright, you get this. Which is the same as this, right? It's the same as this. When any character, exactly, they encode is a character from the Unicode BMP. So it corresponds to the Unicode character with code point of this. So if you want to know is the code point of this, what you can do is, well, let me get the Unicode point of this, so of this character. All right, let me get the Unicode of this sequence encoded from BMP. All right, I want to get the sequence of the number or the code point. I can use the code point add this, and it's gonna give you this, which means that you can now use 169 to represent in hexadecimal to represent that character. All right, which belongs to the basic multilingual plane. Okay. But as explained earlier, many Unicode points as well are above or 64, for example, like this or this, is a decimal code point of this, which corresponds to the funny pilpu. But UIFE wouldn't work to include these characters in a string, since it will be parsed as the Unicode escape sequence this, followed by the literal 9 character. To address these limitations, a variation of Unicode escape sequence was introduced to allow an arbitrary number of hexadecimal characters after the U be surrounded by curly braces. So, for example, if we want to do this, all right, if we want to do this, Recall the early discussion of extend non-BMP Unicode character as surrogate health. The same could also be defined with two explicit code units, then form a surrogate. Even though poop looks like a single character, its internal representation affects things like length computation of a string with that, which is something that we already saw that. The other is Unicode formalization or normalization. Okay. I think this is something that I already saw that. The normalization. Alright. Which length computation. Exactly. With length computation. Template literal. Something that I'm quite familiar with. Template literal. All right, and then we reach two number value. Let me see. Okay, and then we reach two number values here. Okay, now that we went through all of this string behavior that we need to know, okay, and the parsing versus coercion and the number values, which is quite an extent topic. Plain boring number to exponential, and the internationalization binary bit representation of this, number limits, safe limits, double zeros, invalid number, big integers values, symbols, if you want to store now secrets to that. The symbol type contains opaque values called symbol. This value can only be created by the symbol functions, like secret symbol, my secret. Just as with big int, the symbol function might be called without a new keyword. You could think of symbol as if there are monotonically incremented integer numbers. Indeed, that's similar of how at least some JavaScript engines implement them. But the engine will never expose any representation of the symbol or the line value in a way that your program can see. So this is internal representations of this. Okay. So that'll be all for this video of the stream. Take care. Bye-bye.